last idea we're going to look at in quadratics is this idea of quadratic identities. We've seen identities before. We saw it in trig. We called them trig identities. All an identity means is something that is exactly equal to something else. That's all identity means. So if you've got two quadratics that you know are equal, but they have to be equal for more than two values of x, then A1 must equal A2, B1 must equal B2, C1 must equal C2. Now the reason why it must be for more than two values of x, imagine drawing both of those on a number plane. Now, if they missed each other, there would be no x values. If they just touched each other, then there would be one x value that would be the same. If they cut through each other, you could have two. But as soon as you get more than two values of x, then they must be the same parabola. They must be the same parabola. Because it's not like you can put one sideways, because they're both x squares. So, more than two, it's the same parabola. So if it is the same parabola, then the coefficient of x squared must equal the same coefficient on the other side. Coefficient of x and so on and so on. So that's the basic idea. Rather than saying this is equal to this for more than two values of x, often you'll see them use the congruent symbol instead. Congruent meaning exactly equal to. Okay? So it's an identity. So we see that. We know the coefficient of x squared must equal the coefficient of x squared, coefficient of x must equal the coefficient of x, and the constant must equal the constant. So what we need to do is to work out which is which. So I could expand the right-hand side out and then group the x's together, the x squareds together, and the constants together. So ax squared and so on. From there I can now say, well, a must be 2. Coefficient of x squared must equal coefficient of x squared. 4a plus b must equal negative 7. Coefficient of x must equal coefficient of x. But we've already just worked out that a is 2, so we can work out b. And b then becomes minus 15. And then we can say, 4a plus 2b plus c must be negative 4. The constant number must equal the constant number. But we now know what a and b are, so we can work out c. And there they are. Another way I could have done that, I could have done clever substitution of numbers. For instance, if I let x equal negative 2, then the x plus 2 is going to become 0. And so if I sub in x equals negative 2, I'll get the value of c straight away. Because the ax plus 2 all squared becomes 0. Bx plus 2 becomes 0. So on the right-hand side, I'm only left with c. And when we substitute that in, sure enough, it becomes 18. If I sub in x equals 0, because that's usually an easy number to substitute in, I'll get an expression like this. 4a plus 2b plus c is negative 4. That breaks down because I now know c is 18. I get 2a plus b is negative 11. If I use x equals 1, I can get another expression, and I'll get 3a plus b is negative 9. I've now got simultaneous equations I could do to find a and b. So we solve those simultaneously. I end up with a is 2, b is negative 15. There's yet, did I put it here? No, I didn't. There's yet another way I could have done this. The x equals negative 2 would give me the c straight away. If I look at this logically on the right-hand side, there's only going to be one thing that will produce an x squared. So I know a must be 2, because nothing else is going to expand out and give an x squared. So I've got c is 18, a is 2, and then I can just pick another number to substitute into and work out b. So you can use a combination of all the different ideas to come up with the answer. So 8i, not too many there. Oh, gosh, I was feeling generous, wasn't I? 1, 4, 5, 1, 2, 3, 4. 6 questions? Cool, it is rather generous. Anyway, there we go. We'll have a look at that idea of quadratic identities.